Hello friends, welcome back to our channel STM Mechatronics. So in this video we'll see the extended calculator functionality. So in our previous video what we have seen is we have used a 4x4 keypad matrix, right, to interface and get the calculator functionality. So this was the keypad that we have used in our previous calculator project, right? So we are going to use now this new keypad, okay, to get more functionality. So which functionality we will be covering in this? So we will be covering like sine, cos, tan, in addition to the previous arithmetic functionalities like add, subtract, multiply, divide, right, and the modulus. So along with this we will have sine, cos, tan and root functionality embedded into our code. Okay, so first thing that we need to do is we have to connect this fifth column to PA8. So we have to connect fifth column to PA8. Now I'll zoom into the connections. Okay, so as you can see, PA8 5, this is connected to PA8. Okay, and column 6 is connected to PB9. Okay, so four pins are connected to rows and 6 pins are connected to columns. Okay, we have not made any changes to the LCD connections. Okay. Now coming to the code, first thing that we need to change is we need to verify that we have configured the pins. Okay, in our previous video that we have seen that we have configured only 4 pins, right, 4 rows, total 8 pins, 4 rows and 4 columns. Now in addition to the 4 columns we are adding 2 more column pins, right, PB8 and PB9. Okay, so we are using PB8, PB9, GPIO port B, pin 8, GPIO port B, pin 9. Okay, so column 6, column 5, right, columns pin 6, column pin 5, that we have defined. Now if you see, right, in the previous calculator project, for first row, first column we have key 7. Okay, but here if we see first row, first column we have on off key, so we have to reassign these key functionalities. So what we will do is we will go over here, see from row 1, column 2, 3, 4 we have 7, 8, 9, right? So row 1, column 2, 3, 4, 7, 8, 9, then multiply and divide, okay. For on off functionality we have done is we have added new symbol, that is at the rate, or we can use any other symbol at the rate. Okay, so we have done that. Okay, now for row 2 we have sine functionality, 4, 5, 6 minus and sine. So sine functionality, that is plus minus sign, that we have implemented using $key. Okay, 4, 5, 6 minus, and for trigonometry sine functionality we have s as a character key. Now coming to the row 3, we have modulus 1, 2, 3 plus and cos. So we have modulus 1, 2, 3 plus and cos, trigonometry cos as c. Okay, now in row 4 we have root 0 dot decimal pointer equals to plus and tan. So for root functionality we have taken as hash sign 0 decimal equals to plus, and for tan, trigonometry tan, we have taken as t character. Okay, so we have modified this. Now in lcd.h we have not modified anything. Okay, the code is as it is. In keypad.h it is as it is, rest of the functionality is as it is. Okay, now coming to the main function. Now first what we will do is we have reassigned the keys, right? So we will check whether our digits are getting properly displayed from 0 to 9. Okay, these are being properly detected or not, that we will see. Okay, so if you remember in the last video, whenever we are starting our project, whenever we are powering up the project, we will get STM Metatronics displayed in the first row of the LCD, right? In the second row we were entering the numbers, so from 0 1 2 3 4, okay, we'll do 4 5 6 7 8 8 9, right? These numbers are properly being displayed. Okay, now what we will do is we'll clear this. So whenever we are pressing this clear function, everything that has been entered will get cleared. Even the results, the numbers, the addition or the result of the previous arithmetic functions, right? All those things will get cleared. Okay. Now we'll see the basic functionality that we have also seen in our previous calculator project. So you can refer to the calculator project how we have implemented the arithmetic functionalities, right? So we will do is 15 plus 85, we should get as 100, that we are getting properly. Now we will do, what we will do is 105 minus any number, like we are taking 125, so that we will get the negative result. So we will do is 105 minus 125, we should get the negative result, right? Minus 20, so that we are getting. Now we will test the multiply functionality. So what we will do is we will multiply 8 into 5, so we should get something, so we should get 40, we should get 40 as a result, right? We are getting 40 as a result. Now we will do divide operation, so that we will get the floating point result. So for that we will divide the even number by some odd value. Okay, so we'll take 80 divided by 7. Okay, so we'll get 11.42. so if we multiply 7 by 11, we will get 77, and we should get 3 as a remainder. So we will do the same operation, divide 80, and we will perform the modulo operation. So 80 modulo 7, we should get 3 as the answer, right? We are getting 3 as the answer. So this functionality is correctly working. Now we will do the sign functionalities. Okay, so what we will do is minus 5 into 8, so we should get minus 40. So that result we are correctly getting. Now what we will do is we will multiply minus 5 into minus 8, so we should get plus 40 as a result. So in that way we can verify that our sign functionality in both way it is properly working. So we are getting plus 40 as the result. Okay, so we have seen that our sign, modulo, then clear or on off, okay, then plus, minus, multiply and divide functionalities are properly working. Now we will see the decimal point functionality. So what we will do is we will add 15.5 plus 4.5, or we will take 44.5, 0.65 we will take. So we are getting the decimal point value also correctly. Okay, so it means sign, modulo, then these arithmetic, 4 arithmetics, plus, minus, multiply and divide, and decimal pointer, these keys are absolutely working fine. Now what we have to do is we have to integrate the root functionality, sine, cos and tan functionality into our code, correct? So for that what we will do is, first thing we will go over here. Now in our previous video this key, right, this key was something different, so we need to check, verify. So whenever we are pressing the clear function, and clear functionality is from row 1 column 1, so we'll check, we'll go over here, the clear functionality, we have implemented the clear functionality over here. So we will be mentioning that key row 1 column 1, that will clear everything displayed on the LCD, and it will clear, basically clear every number. Okay, so the clear functionality will set the clear flag. The clear flag will clear everything, the num1 value stored, the stored number 1, the stored number 2, the result, right, of the previous arithmetics, the previous where key, the previous arithmetic key that has been entered. So it will clear everything. Okay, now this is the result key, output key, right, equals to, so using this we will get the output of the arithmetic functions, arithmetic, sine, cos, tan, everything. Here we are entering the numbers, full number, right, or the decimal numbers that we are entering over here. Now we have implemented dollar, right, so this is used for sign, plus minus sign. So we need to check that it is correctly implemented, right. So row 2 column 1, that is plus minus, right, sign functionality, row 2 column 1, row 2 column 1, it is sign functionality. So for this we are using dollar sign. Okay, so for sign functionality we are using the dollar sign. Now coming over here, right. Now if we are, rest of the code is similar to that of the previous calculator project, right. So I'll tell you what modifications that we have done. Okay, we are not changing this display float, or we are not modifying this display float function. Okay, neither we are modifying this okay, we are not modifying this display function. We are little bit modifying this calculator functions, because we have added two or three more functionalities, right. We are not changing this convert array into number function, so we are only modifying this calc function. Okay, now coming to this function, right, we are keeping these functions add, subtract, multiply, and divide function as it is. Okay, we are keeping the remainder functions, modulo functions as it is, right. So whenever modulo key will be pressed, right, the result will be num1 modulo num2. So the modulo functionality is fairly simple. We are entering two numbers, right, we are dividing first number by second number, and whatever remainder we are getting, we are printing in we are returning from this remainder function. Okay, so modulo function, that is the basic functionality of the modulo. Now what we are adding is root functionality, sine, cos, and tan functionality. These four functionality we are adding. Okay, 4 or 5 functionality we are adding. So root functionality is like, so whenever we are pressing row 4 column 1, right, whenever we are pressing this key from row 4 column 1, we should get the root value, root of the number that we have entered. So for that we are implementing, like, whenever we are pressing key which is from row 4 column 1, that is the root functionality, we will be returning the root of that value. So we are only entering one number, and when we are pressing the root key, so the root of that number will be returned or displayed as the result. Okay, so sine, now sine is on row 2 column 6, cos is on row 3 column 6, and tan is on row 4 column 6. So sine is on row 2 column 6, cos is on row 3 column 6, and tan is on row 4 column 6. So we have implemented, like, row 2 column 6 is for sine, row 3 column 6 is for cos, and row 4 column 6 is for tan functionality. Okay, now where this functionality have been implemented, this functionality have been implemented into arithmetic.c file. Okay, so if you remember, we have previously in our calculator project also, we have these 4 functions, 4 or 5 functions including the remainder functions. Okay, now we have implemented like the root functionality. Coming to the root functionality, if we are entering the negative number, it will simply result return error. Okay, so whenever we want to get the root of any number, the number must be positive number, then and then only we will get the correct result. Okay, so we are entering like, if the number is negative, right, it will return error. Same goes for cos functionality, same goes for tan, sine, cos and tan functionality. Okay, now coming back to this root function, we are returning square root of the number that we have entered. So this is fairly simple that we have implemented. Okay, I'll explain where this square root function is coming from. Okay, now see, if num1 is greater than 360 degree, so we are basically taking the number as radians. Okay, num1 in radians. Okay, so what we are doing is, if the number is greater than 360 degree, we are simply reducing 360 from the number. Okay, and we are storing in the same number. So after storing into same number, we will be returning the sign of that number. So we are basically printing the sign of numbers from 0 to 360 degree, which are in radians. Okay, same goes for tan, cos and tan. If the number is greater than 360 degrees, then we are putting them into while loop, right, until the number becomes less than 360 degrees or equals to 360 degrees. Okay, similarly over here, right, similarly for tan. Now these sine, cos, tan, these are trigonometry functions, but those are available into this library function mat.h. So we have included mat.h into arithmetic.h file. Okay, we have added the prototype declarations, right, into this sine, cos, tan, root, remainder or modulo functionality, right, over here. Now coming over here, now we'll check whether this functionality is correctly working or not. First, what we will do is, we'll get root of 15. We'll check on calculator root of 15 root, right? So we will get 3.8729. Now we'll do over here, we'll get 15 and then we'll press root. Okay, so we'll get 3.87298. So if you see 3.87298, up to 5 digits, 5 decimal points, we are getting the correct value. So 3.87298, we are getting the correct value. This means our root functionality is working properly. Again we will do what? 600 root of 600. Okay, square root of 600. So we should get 24.49489. So we should get 600 root of 600, 24.49489. So we are getting the correct value. Now we will do sine, cos and tan functionality. So what we will do is, we will get sine of 150, right? We should get 0.5. So we will do 150 sine of 150, right? And then we will press OK. So we are getting minus 71487. Now if you see, we were entering into degrees. Okay, what we will do is 150 sine of 150. So we are getting 0.71487. So we will do again 150, right, sine of 150. We are getting 71487. So it is matching with our calculator results, right? Now we'll do cos of 270, or we'll do 275 cos of 275, right? So we should get 11041. We should get 11027. So we are getting 89438. So I guess this is something different. Cos functionality is giving error. We'll look into it, why it is giving error. Okay. Now coming to tan functionality, we'll check 375. Okay, cos of 375. So we'll check 375. Sorry, tan of 375. We should get 2.2373. So we'll put tan of 375. We should get something, some value is getting different, right? So we need to debug this. Go to our arithmetic functions, arithmetic.c. If the number is lesser than 0, we are simply returning 1, minus 1. If the number is greater than 360, we are reducing 360 from that number, and then we are again storing into the same number. We are checking whether it is greater than 360 degree. If it is, then we are again doing this. So we should get cos sin tan, right? Cos sin tan, tan of 15 should be 15 tan should be 85599. So if we check tan of 15, right, it is correct. So 85599, we are getting the correct value, 85599. Okay, then what should we do is we should enter 270, right? 275, then cos of 275, we should get 11041. So we'll do is cos of 275. So we are getting 11041. So our sin, cos, tan functionality is correctly working whenever we are entering the number which is lesser than 360. Okay. So in such way our calculator, advanced calculator functionality has been implemented. So if you like my explanation, if you like the video, please hit on like, share with your friends and subscribe to our channel. Thanks for watching the video. We'll see you into next video.